Hi everyone, in this video I'm going to do resistivity. Resistivity using symbol P, or this symbol that you see is defined as the resistance between two opposite sides of a unit Q. Or resistivity is the resisting power of a specified material. Resistivity is how strongly a material resists the flow of electric current, whereas the resistance is the opposition offered to the flow of electric current. So resistance uses the symbol R, capital letter R, but resistivity it will be P, or this symbol. We know it as density in hydraulic. So in electricity, it will be a symbol to calculate resistivity. There are factors that affect the resistance, or the factors that influence the resistance of a conductor. A resistance of a conductor depends on the type of material. Type of material is the resistivity, and this is the symbol for a type of material. The SI unit of a resistivity is ohm meter. The second factor is the length of a conductor. The bigger the length, or the longer the length of a conductor, there will be more resistance offered, and it must be in meters. The third factor is the cross-sectional area. The bigger the area, there will be lesser the resistance. It must be in square meter. And the last one is the temperature. The symbol is T and is measured in degrees Celsius. Now, when a temperature is kept constant, this will be the formula to calculate the resistance. The resistance is equal to resistivity because it's proportional to the resistivity. Also, it's proportional to the length of a conductor, but inversely proportional to the area, because when you increase the area, there is less resistivity. When you increase the length, there is more resistance. When you decrease the length, there is less resistance. So it's proportional to the resistivity and the length, but inversely proportional to the area. When you make resistivity the subject of the formula from the first equation, resistivity will be resistance multiplied by area. So resistance is measured in ohms and area is measured in square meter, divided by a length that is in meters. So a meter will cancel 1 meter on the numerator and will be left with this SI unit. When the temperature is kept constant, only the length, area, and type of material that will have an effect. So when a question says list 4 factors, you give all 4. If a question says list the factors that influence the resistance when the temperature is constant, it means you're not going to list the temperature because it's constant. A relationship between resistance and the factors that affect it. The relationship is this one. The length is directly proportional to the resistance. When the length increases, there is more resistance. When the length decreases, there is less resistance. It's proportional to the length. Second factor, resistivity or type of material is directly proportional to the resistance. Also, it depends on the type of material. Each and every material has its own resistance. The conductors of electricity, the good conductors, they have less resistance. And the materials that do not allow electricity to flow easily through it, they have the high resistance. Number 3, another factor is cross-sectional area. What is its relationship? It is inversely proportional or indirectly proportional to the resistance. When the area is bigger, resistance is less. When the area is less, resistance is more. And the last one is the temperature. Temperature is directly proportional to the resistance. So the hotter the substance, there is more resistance. Let's look at the activities or the examples taken from different past question papers. Number 1 says a conductor has a length of 12 meters and a cross-sectional area of 2.2 times 10 to the power negative 5. The resistivity of the material is 1.16 times 10 to the power negative 7 ohm meter. It says calculate resistivity is P. Calculate the resistance of the conductor. So resistance is R. The unknown is R. Let's look at question paper formulas. This formula will be given in exam. So you can be asked to calculate a resistance R. You can be asked to calculate a resistivity P. You can be asked to calculate the length of a conductor L, or can be asked to calculate the area or a diameter. A conductor of material, it is circular. If you are given a circular in shape, the formula to calculate an area is pi d squared over 4, or it's pi r squared. Now let's look at the solutions. All the given are there. The formula is resistance is equal to resistivity multiplied by length divided by an area. So resistivity is in its correct units. If it was given maybe in micro ohm meter or milli ohm meter, we're going to first get rid of the prefix. So resistivity is 1.16 times 10 to the power negative 7. This must be multiplied by the units of L are correct, are in meters. So it will be 12 meter. This resistivity is in ohm meter. Divided by an area must be in square meter. So the units are correct. It will be 2.2 times 10 to the power negative 5 square meter. So this meter and this meter will give us a square meter, and the square meter will cancel this one, and we'll be left with ohm, which is the SI unit of the resistance. Now we can use the calculator to get the answer. It's 1.16 times 10 to the power negative 7 multiplied by 12 divided by 2.2 times 10 to the power negative 3. And the answer is 0.0006. 0.000633 ohms. That will be the answer. Let's look at the second question. So if your calculator gives the answer in exponential form, if a calculator gives the answer in exponential form, if it says is 6.327 times 10 to the power negative 4, you're going to write that answer as it is with that exponent. Second question. Calculate the diameter of an aluminum conductor in millimeters if the length of is 75. So L is given as 75 meters The resistance is 0.65. R is 0.65 ohm at 20 degrees Celsius. So T is given as 20 degrees Celsius. Calculate the diameter. So we're going to get the diameter from a formula of an area. A diameter from a formula of an area. Now you are given that it is an aluminium. Since you are given the type of material, we're going to get resistivity from the table. Not all the questions, they will give the resistance. In some questions, they will tell you what type of material is that. Then you need to use the table of constants to get the resistivity. So the formula stays the same. It depends which quantity you're looking for. It will remain R equal to PL divided by area. The formula stays the same. Now let's look at table of constants. There's the resistivity. Resistivity of aluminium at 20 degrees. This is the given resistivity of aluminium. So I'll take it from the table. It's 0.367 to 8 ohm meter. That is the resistivity from the table. If it's not given, you get it from the table. Where there is a resistance is given as 0.65. I'm going to put 0.65. It must be equal to resistivity from the table is 0.7028. This must be multiplied by the length is 75. So it's times 75 divided by an area. Area is the unknown. When you cross multiply, this will be area times 0.65 equal to, this is over 1. So it will be 1 times this answer this side. It's 0.123456728 times 75. The area, this side is 0.50. Then divide both sides by 0.65. Both sides by 0.65. Cancels out this side. The area will be equal to 0, or we can put it in exponential form. If your calculator gives you 3.2 times 10 to the power negative 6, it will be in square meter. If your calculator gives you 3.23 231 times 10 to the power negative 6, 3 decimal after the comma, yeah. So this will be the correct one, square meter. So this is the answer. We got to the area, but the question says calculate the diameter. So you must use the formula of an area. Let's look at the question again. It says calculate the diameter. There's a question. Calculate the diameter of an aluminium in millimeters. The formula to calculate an area that is circular or round in shape or a cylinder is pi over 4 d squared. So an area, we calculated it, is 3,231 times 10 to the power negative 6 equal to pi divided by 4 multiplied by d squared. This side is over 1. Cross multiply, this will be 3,231 times 10 to the power negative 6 multiplied by 4 equal to pi times d squared. Then we're going to divide both sides by pi, both sides by pi. Pi cancels out. The answer will be area which is 3.231 times 10 to the power negative 6 multiplied by 4. And this must be divided by pi. This is 0. Let me put it in exponential form. It's 4.114. 4.114 times 10 to the power negative 6 equal to d squared. The question says calculate a diameter, not a diameter squared. So you put square root both sides, square root both sides. This half cancel the 2 this side. And when you put this answer under the square root, it will be 2.028 times 10 to the power minus 3 meters. And 10 to the power minus 3 stands for milli. So this is 2.028 millimeter. That is the diameter in millimeters. Next question. Calculate the resistivity of a conductor 10 kilometer long with the resistance of 20 ohm. The resistance is 20, length is 10 kilometer. And the resistance is 20 ohm. The diameter is 10 millimeter. So sometimes you can be given a radius. You multiply radius by 2 to get the diameter. Calculate the resistivity. So the unknown here is P. Let's look at the solution. Formula is the same. Resistivity is PL divided by an area. So we can first calculate an area aside. An area is calculated by a formula pi d squared over 4. And it will be equal to pi multiplied by a diameter is not in meters. It must be in meters in order to get the correct SI unit of an area, which is a square meter. So from millimeter to meters, you divide by 1,000. So this will be equal to 0.01 meters. You multiply by 0.01 squared. And this is divided by 4. The answer will be pi times 0.01 squared divided by 4. Let me put it in engineering notation. Engineering mode, this is 78.54 times 10 to the power negative 6 square meter. That is an area. To write the answer your calculator gives you. If it gives in decimal form, you write that answer. But you cannot write since the instruction says 3 decimal places and we have 3 zeros after the comma, you can't write 0.000 and it's the end of it. That's why when it comes to these small digits, you can write it in exponential form so that you don't end with an answer that is 0. Calculated the area. Now we can substitute on this equation. The length is given in kilometer, but the correct unit must be in meters. So a kilo is equivalent to 1,000. This will be 10,000 meters. Resistance, correct units. So substitution where there is R is 20, equal to where there is resistivity is the unknown. Multiply by length is 10,000. Divided by area is this one, 78,54 times 10 to the power negative 6. Next step, we put this over 1. Cross multiplication. This will be 20 multiplied by 78,54 times 10 to the power negative 6 equal to 1,000 times P. 10,000 times P is 10,000 multiplied by 1 stays the same. So this will be 10,000 P. Divide, okay, we can multiply this side. This is time 20. And the answer is 1,571 times 10 to the power negative 3. This is equal to 10,000 of resistivity. Divide both sides by 10,000, both sides by 10,000. Cancels out. We can put this on the left-hand side, resistivity equal to you can write the answer your calculator gives you. If it gives you 1.578 times 10 to the power negative 7, this will be ohm meter. If your calculator gives 157.08 times 10 to the power negative 9, that answer is also correct, as long as you're going to write the correct exponent. This is minus 7. Next question, last one. It says determine the length of a copper conductor that has a cross-sectional area of 20 millimeter. So area is given as 20 millimeter. And the resistance R is 0.9 ohm at 20 degrees Celsius. The type of material is a copper. So we're going to go to the table of constant to get the resistivity of a copper. It's 18, so resistivity is 0.1234567 and 18 ohm meter. Calculate the length. Formula is the same formula. R equal to resistivity multiplied by length divided by an area. Resistance is given. Resistivity, we got it from the table because the type of material is mentioned on the table. Area is 20 square millimeter squared. So we need to change this area to square meter. When you change a millimeter, to a meter, we divide by 1,000. When we change a millimeter squared to a meter, it will be 1,000 squared because there is power 2 there. But this m has exponent 1. Same as when you change millimeter to the power 3 cubic millimeter into meters. The relationship is 10 to the power 3, but unit is 1,000, right? But you need to say 1,000 to the power of 3. Same applies centimeter to meters. Is division by 100. But when it is centimeter squared, it will be division by 100 squared. This exponent, it also decreases it. So this 20 millimeter will be divided by 1,000 to the power 2. So this area is 20 divided by 1,000 squared because it's millimeter squared. Then we can substitute where there is resistance is 0.9 equal to resistivity is 0.123456718 multiplied by a length divided by an area is 20 divided by 1,000 squared. 20 divided by 1,000 squared. This is an area. So when you are given a diameter, you need to calculate area first so that you can substitute here. This question we're given the area, that's why we don't first calculate. It is given as area. To calculate area when we have diameter, this is the formula pi d squared over 4. It won't be given in exam. You must remember it. Next step is to use a calculator. 20 divided by 1,000 squared. 20 divided by 1,000 squared. Then this must be multiplied. When you cross multiply it, it's going to multiply this 0.9. So it's times 0.9. The answer is 0. There are 4 zeros and there is 1.8. This must be equal to 0.123456 multiplied by L because this side multiplies by 1. Next step, you divide both sides. This is 1.8. Both sides by 0.123456718. Both sides by 0.00000018. Cancels out this side. This length will be equal to. This is divided by 0.123456718. It's 999,999. So this is 1,000 meters. Or if a question says calculate this length in kilometer, it will be 1 kilometer because 1,000 is equivalent to a kilo. That will be the answer. Thanks for watching.